where we need to find the least number of buses that we take from source to target. So given all these routes, these are the stations in here for given bus. These are another stations for given bus. So bus A contains all of these stations, bus B contains all of these stations, and if path exists, so our source is one right here, if from here, and then from there, if path exists, and then if it's a in this graph, then we need to return how many buses it took us to get to station from 1 to 6. So in here we can see that there are 2 buses, and if it was valid, then it took us 2. So that's the answer. And the way we are going to approach this one, we'll create a adjacency list. In our adjacency list, it will contain the station along with the bus number, basically. And we will perform BFS on this graph, since for unweighted graph, BFS finds the shortest path. If it was a weighted graph, we would have used Dijkstra's algorithm, where we use priority queue. So let's jump right into coding. Let's create map integer, and it will contain a list of buses, basically. So graph new hash map now for integer I 0, our routes length I plus plus. So this I represents the number of our buses. So for now we need to see our station. So for station in given routes I, what we are going to do, we're going to save it into our graph for given station. If it doesn't exist, then we will create a new array list, and whatever the value it comes out from here, we will just add our bus number. So I is our bus number. Now we have created our graph. Let's do BFS on this graph. So for that, let's create a queue, and this queue will contain array where we'll have 2 values, station and then bus count. So for each station, we will be having a bus count. So queue new array deck, and at last, so like I was saying, it contains our station. So what is our source station? It is just source, and then what is our bus count? From here it's just 0, we can just say 0. And let's create our visited buses, because like we need to make sure that every time when we are seeing a new bus, then we are incrementing the bus count. So for that purposes, we need to make sure that we are not processing same buses. So visited buses new hash set. Okay. Oh, now let's process. Let's do BFS. So queue until it's not empty. So while it's not empty, let's remove from our queue, which will be the queue remove first, because it's a FIFO. So first value in our bus, it's our station. Current 0, and for the second value, it's our bus count. Okay. Now, since we have our station, we can actually check if this station is equals to our target. Is the one we are looking for? If it is, then return us the bus count. So if it's not, let's keep processing it and traversing the graph. So for we need to see our graph's value, and values contains this bus. So int bus in each this graph get or default for given station. So if it doesn't exist, then give us empty array list, so it doesn't complain with null pointer. So now if it doesn't exist, then it's just empty array list, and this will not process. This for loop will not do the iterating it. So now we have our bus. Let's check if this is the bus we have seen before. Contains this bus. So if it does contain it, then just continue with next operations. So if it doesn't contain, then let's just add it to our visited bus, because like we are about to process this. Now for given bus, we can actually see the stations. So as you can see, when we were saving it to our graph, this was our index basically. So bus number is our index. So from here, from routes, we can access to our stations. So we can just give so in our station for given routes bus. So this is giving the list of stations. So what we are doing is accessing this by giving bus number. Now since we access this, we can actually add it to our queue. At last, new int array with station was the first one in our queue station, and bus count, and increment it to 1. So what we are doing in here is that our queue is containing the station information along with the bus count. So every time when we see a new bus for given station, we are incrementing the bus count. So this is preventing us to reprocess the same bus, and every time it's just new bus, then we are incrementing it. So when we are seeing this station next time, then we will be returning the bus count out of there. So if here's our answer, if it matches with target, if it's not, then we'll just return -1. So let's run our code. Wow, forgot C. Perfect. Let's submit it. Nice. So about time complexity in here. So the time complexity, it is n times m, where n is all those routes and m is all these edges basically. And m is all those stations that we have, and space complexity, we are using this extra graph right here, visited buses, and in our queue as well. So this is also all m times n, where m is all those routes and m is all those stations.